Here are our solutions for day 6.5 homework. So in question 1, we're asked for each triangle, label the hypotenuse, the opposite, and the adjacent sides relative to the marked angle. Well, in these type of questions, the easiest side to label is always going to be the hypotenuse because it's going to be directly opposite the right angle. So I often put that one in first. Our reference angle is M. So here's our opposite, and there's our adjacent. Question B, once again, opposite our right angle is our hypotenuse. Our reference angle is Y, so here's our opposite, and here's our adjacent. Question C, directly across from the right angle is our hypotenuse. Our reference angle is T. There's our opposite, and there's our adjacent. Question D, directly across from the right angle is our hypotenuse. Our reference angle is E, making this our opposite, and this side our adjacent. Question E, directly across from the right angle is our hypotenuse. Our reference angle is J. Directly across from J is the opposite, and beside it is our adjacent. This one, directly across from the right angle, hypotenuse. Our reference angle is C, so there's our opposite, and here's our adjacent. Question 2. Write the ratio comparing the length of the opposite side to the marked angle to the length of the hypotenuse. Then express the ratio as a decimal, rounding to 3 decimal places. Well, our marked angle is S. And we're dealing with opposite and hypotenuse. So we look down here at our chart, and the trig ratio that has to do with opposites and hypotenuse is the sine. So here's our opposite, here's our hypotenuse, so we can say that the sine of our opposite, which is 5.8, over our hypotenuse, which is 10.4, looks like this is a fraction. And then when we crunch the numbers in our calculator, we end up with a decimal of 0.558. So we can say that the sine of angle S equals 0.558. Question 3, write the ratio comparing the length of the adjacent side to the marked angle to the length of the hypotenuse. So our reference angle is H. So here are our labeled sides, adjacent, hypotenuse, and opposite. We're talking about adjacent and hypotenuse. So we come down here to our chart, we find adjacent and hypotenuse, and that has to do with cosines. So we can say that the cosine of H, which is the adjacent over the hypotenuse, equals, the adjacent is 12, the hypotenuse is 13, and we take 12 over 13, we put it into our calculator for a decimal of 0.923, so we can say that the cosine of H equals 0.923. Question 4, write the ratio comparing the length of the opposite side to the length of the adjacent side for the marked angle. Well, our marked or reference angle is R, so we'll bring in our labels. And we want opposite and adjacent. So we look down here and we see that opposites and adjacents deal with the tangent. So we can say that the tangent of R equals opposite over adjacent. The opposite is 24. The adjacent is 29. We put those values into our calculator and get the following decimal place. So we can say that the tan of r, or the tangent of r, equals 0.828. A wheelchair ramp reaches 1 meter high at its highest point. The length of the ramp is 8.4 meters. So question A wants us to use the Pythagorean theorem to figure out what the length of the ramp is. So this is our hypotenuse. So we can say that c squared, this value up here, will equal a squared plus b squared. Using these values, we can say that c squared equals 1 squared plus 8.4 squared. C squared equals 1 plus 70.56. C squared equals 71.56. And if c squared equals 71.56, then c by itself equals the square root of 71.56, which happens to be a value of 8.5. So our ramp is 8.5 meters long. Question B asks us to find the ratio of the length of the opposite side to the length of the adjacent side relative to the angle the ramp makes with the ground. Well, the angle that the ramp makes with the ground is this angle right here, which is G. So that will make G our reference angle. Now, it's using the terms opposite and adjacent. So opposite and adjacent has to do with tan ratios. So we can say the tangent of our reference angle, G, equals opposite over adjacent, which happens to be 1 over 8.4. So we put that into our calculator, and we get a value of this. So we could say the tangent of our reference angle, G, equals 0.119. And question C asks, what other term could we use to describe this ratio? Or what is a word that can describe how steep this ramp is? When we're talking about steepness, we're talking about the slope of the ramp. Question 6 says, use the following diagram to answer the following questions. Question A, use the Pythagorean theorem to find the length of the third side. Well, B is our third side. We're given the hypotenuse, and we're given this side, so we need to figure out what B is. So we can state that, using the Pythagorean theorem, 13 squared equals 5 squared plus b squared. 13 squared is 169. 5 squared is 25 plus b squared. Now we want to isolate b squared, so we can say b squared equals 144. If b squared equals 144, then b by itself equals the square root of 144. Sorry, that should be b. B is therefore 12 meters. Find these ratios. Round your answer to 3 decimal places. They're asking, what is the ratio of the opposite side to the hypotenuse relative to angle A? Well, here's angle A right here. Here's the opposite. And here is the hypotenuse. So when we're dealing with opposites and hypotenuse, we're dealing with sines. So we could say the sine of angle A equals the opposite over the hypotenuse. So in this case, 12 over 13 is the opposite over the hypotenuse. And putting this into our calculator, we could say the sine of A equals 0.923. Question C asks, what is the ratio of the length of the opposite side to the length of the hypotenuse relative to angle C? Well, here's angle C right here, and we're dealing with opposites and hypotenuse. Once again, opposite and hypotenuse is sine, so we can say that the sine of angle C equals opposite over hypotenuse. Notice how we change the reference angle to C, therefore our labels change. So here's our opposite, here's our hypotenuse now, and that is 5/13. Sine of C equals 0.385.